Hey students, welcome back to Diksha Vedanto English channel. This is Suhas, your chemistry master teacher. Students, in this video, we discuss overall carbon and its compounds units under 30 minutes. Okay students, come on, let's go. Before entering to the class, please do not forget to like, share, subscribe the channel and also Telegram channel. The Telegram channel link is there in description. If you want this PPT, the PPT after the video, it is uploaded in description. Please download it. Okay students, let's start with the introduction. We already know carbon is a 92. Among 92 naturally occurring elements, carbon is the 15th most abundant. Please note down this point, 15th most abundant. In our body, Totally, how many percent of carbon is there? 18.5% of carbon is there. Carbon is obtained in different forms, right students? In natural fibers, in cotton, wool. It is also carbon is present. Carbohydrates. In carbohydrate is nothing but protein, fats, glucose. Everywhere carbon is there. And also gases like carbon dioxide, bicarbonate, marble. Everywhere carbon is there, students. This is about introduction. In occurrence, carbons occur in two states, okay? First state is an free state and second state in combined state. Free state is nothing but as element like an diamond, graphite and other things. Right, diamond, graphite and coal. These are all the element. Combined state is nothing but gases, CO2 gases, carbonates, this thing. Okay students, these are the example for free state carbon. Okay, graphite is there, coal is there, diamond is there, and also these are the other compounds. They are obtained in the what? Combined state. Limestone, marble, chalk, petroleum, these are all the carbon sources obtained in the form of a compound. Okay, in the combined state. Occurrence of carbon. Let's discuss occurrence of carbon, students. Let us consider few examples. Here, see, before previous year, our astrologers, or not an astrologers, our scientists is there now, students. They have one few things, okay, about carbon. Oh, carbon or organic compounds is nothing but the compounds or the substance are obtained from the natural resource like sugarcane juice and other thing. These are only carbon units. They think like that. But at 18th century, the scientist name called Friedrich Holler, he proved wrong. He proved first organic compound synthesis in laboratory. He synthesized first organic compound in laboratory. The compound name is ammonia cyanate or urea. We are familiar with urea, right? Especially the farmer kids, as we use this urea in our fields, right? Urea is very important. This is an first synthesis organic compound. Students, this is very important, not for your board exams, for your higher studies, for your competitive exams, okay, CA exams. Okay students, I hope it's clear. Next, move for the bonding in carbon. Very important topic, bonding in carbon. Here carbon having 6 important points. What is the symbol of carbon, students? Symbol of carbon is C and atomic number of carbon is 6 and atomic mass is 12. Simple, right? And also carbon having 2 important bonding property, or to have an important property. One is called as catenation. Catenation is nothing but it has an ability to form a long chain bond with an same carbon atom, C. This is called catenation property. And tetravalency, it has how many free electron present in the, not a free electron, how many electrons present in the valence shell in carbon? Its electronic configuration 2s, right? In S shell 2 and 4 in P shell, right? Next shell, it has an 4 valence electron present in their valence shell, right students? For this, we already know every atom have a tendency to attain electronic configuration same as a noble gas, right students? It is nothing but, what is the stability? Stability is nothing but in outermost valence electron, the atom consists minimum how many electrons? 8 electrons. Here we have two possibility, right? In outermost valence shell, totally 4 electron is there. Either they give 4 electrons or they accept the 4 electrons. For removing 4 electrons, we want so much energy, students. That's why it's not happened. And also, if we add or it accepts 4 electron and it becomes C4 minus, what happened? How many total number of proton present in the nucleus? Here 6, right students? Always number of proton is equal to number of electron. We know, we already studied in class 9. 6 electron is there. 6 proton. It is difficult to hold the 10 electron from 6 electron, right students? Balancing. 6 electron is one side, 6 proton in one side, 10 electron in one side. What happened? It not balanced. That's why it's not happened. For this, to come this problem, carbon forms a new chemical bond. It is called covalent bond. What is covalent bond? These are the chemical bond. These are the bond formed by sharing of its valence electron. For example, CH4. It is a simplest covalent compound. Okay, students, in MCQ they may be asked which is the simplest covalent compound. It is CH4. And also catenation and tetravalency property, very important. Why carbon not form C4 minus charge or C4 plus? Why? Because we need to tell the reason. Okay, and also what is covalent compound is also important. Covalent compound, covalent bonds. Covalent compound is nothing but the compound containing covalent bonds. What are covalent bond? Very simple. The bond formed by sharing its valence electron. Very simple. Next, move on to the covalent bond. Let's move on to the already covalent bond is clear. Types of covalent bond. In covalent bond, we have mainly three types. Single covalent bond is there, double covalent bond, triple covalent bond is there. Single is nothing but name itself we can easily explain. Each atom contributes only one electron is called single, 2 electron is called double, 3 electron is called triple. Very simple. Okay, let us find out. Here, let us discuss the structure of methane. One carbon, what is the valency of carbon? 4. What is the valency of hydrogen, students? Hydrogen valence is only 1. Right? Maybe it give 1 electron, maybe it accept 1 electron. Sometimes that's why we never consider hydrogen as an either metal or non-metal. Sometimes it's below, it's what happened? It give 1 electron and behaves as an H plus. It accept 1 electron, it behaves as an H minus in some cases. That's why we never consider it's a metal or non-metal. Okay, students. What happened? It contribute 1 electron, carbon contribute 1 electron, forms an 1 covalent bond. Here, how many covalent bonds is there? 4 covalent bonds. That's why this is called single covalent bond. This is very important. Please take a screenshot or I share this PPT. Please download this. Versatile nature. Very important. Explain the versatile nature of the carbon. What is versatile nature? Carbon have a capacity of forming multiple bonds. How many bonds it form? Multiple bonds. Maybe single, maybe double, maybe triple. Why? Because CC double bond is there, CC triple bond. Catenation property. Catenation property, students. Okay, some other carbon atom and also other atom like oxygen and nitrogen. What is the valency of oxygen? C, right? It forms CO2 gas. And CN, nitrile group. Okay, students, this is very important because due to smaller size and also tetravalency property. This is about bonding. Okay, versatile nature. And also another important thing is there, catenation property. Very important. Please note down this point. Catenation property, the ability of an atom to join with the other atom of the same element. This is called catenation property. In our periodic table, two atoms have this property, mainly carbon, and second one is an there. Where is that? Second one is an Si, silicon. Second one is other than silicon, but not like carbon. In carbon, we have so many chains. For example, straight chain, it forms a straight chain, branched chain, and also closed chain or coordination ring chain. These chain you are we are discussing last of the session, and also in higher studies these are very important. This is about versatile nature. Let's move on to the allotropes. What is allotrope? Student, allotropes is very simple and also very important. Why now? Because in metals and non-metals, we know all non-metals are soft except this diamond, right? All non-metals are poor conductor of electricity except which? Come on, let me know. Except which? Let me know on chart section, not in chart, in comment section. Okay, students. What is allotrope is nothing but the chemical properties of these different forms are same, but physical properties different. Some have an hard in nature, some have an soft in nature. It's very simple. These are the another form of a carbon. Their physical property varies, but not in chemical property. Chemical property same, physical property varies. These are called allotropes. In diamond is there, graphite and fluorine. These are the three very important allotrope. Let's move for the. We divided into crystalline, amorphous. Amorphous is not at all important. In your syllabus, only crystalline is there. Please concentrate on syllabus. Okay. Occurrence of diamond. In these countries, diamond is there. America, Brazil, South Africa, Russia, Belgium, many cases diamond is there. Let's move for the structure of diamond. Diamond has 3D structure. Here look here, students. One carbon form and bond with 3 carbon in the case of 3D. Like film, what happened in 3D? We watch in 3D now. What happened? We feel and what? Reality, right? We feel reality. The fight is come in our eye, right? In front of our eye. Similarly, this thing is happened. This is about the structure of diamond. Next, move on to the properties. These are the properties of diamond. First property, it has a brilliant and pure diamond in the Hardest natural substance, it is hard, it has a density across 3.5, melting point of diamond is high. Okay, then diamond does not dissolve in any solvent. Any solvent it does not dissolve, students. Next, move on to the uses. Okay, these are the reasons. Why? Because odd, because it has a rigid 3D structure. High density, why it has high density? Because it has a compact and rigid 3D structure. Right, students, this is about high melting point and it is a non-conductor of electricity. Uses, we already know in jewelry we use it and also in industry to cut, because it is an hardest substance, right? That's why. And also in surgery, diamond, knives, more uses is there. Next, move for the graphite. These are the countries obtained the graphite mining. India is also there in graphite mining. Okay, students, it is different. Graphite structure is different. Graphite has a layer of graphite. Okay, a graphite crystal consists of carbon atoms or sheet of carbon atoms. It has a sheet of carbon atoms. Look here, sheet of carbon atoms. And also one layer of graphite is called as an graphene. Very important, graphene. Carbon atom is in graphite, carbon atom arranged in hexagonal shape. Okay, 6 shape. Here they, here see, and both sheets are attached one by one, is placed one by one. Okay, students, this is the structure. See here, this is a various layer linked together. Okay, and next more the property. Students, in carbon we have a free electron. In graphite, okay, in graphite we have a free electron. Why? Because one carbon is forming bond with two another carbons in hexagonal ring, then another carbon in next ring. Okay, one carbon is free. That's why graphites are used in many electrodes. Why? Because they are good conductor of electricity. Very important. Note down this point. And also density of graphite is too low compared to diamond. Okay, and also these are slippery. Why? It one layer is placed on another layer, right? That's why it's slippery. Next, move on to the property. This is the reason. Why soft? Because sheet-like structure. Good conductor because one valence electron is there, one free electron. Slippery layers can be slide one another. These are the uses. It is used in lubricant for machine parts. Very important. In exam they ask, mention the uses of graphite, diamond, this thing they have. Okay, please note on using making of electrodes. And sometimes they ask, graphite is also a non-metal or it is an allotrope of carbon, but we use it as an electrode. Why? It is some competency based question. Note down those question. Then students, next, fluorine. Very important. Why it's called as a fluorine? Because this named after US architect Fuller, because it is look like a bowl. Okay, this is are the type of fullerenes. Okay, these are the example. Property. First property, molecules of fullerenes found in the form of buckyballs or buckytubes. Okay, buckyballs and buckytubes. This is the first one, and there are 30 to 900 carbon atoms. It's nothing but it's a big fullerene is a big shape and it consists more carbon atom. Okay, students. Next, move on to the very important topic, hydrocarbon. What are hydrocarbon? In name itself, it indicates hydrocarbon. The compound, the organic compound, especially the organic compound containing both carbon and hydrogen. These compounds are called as an hydrocarbon. Only carbon and hydrogen. Okay, contains hydrogen. Every organic compound contains hydrogen and carbon, students. Very important. Okay, and hydrocarbons are divided into two parts. Hydrocarbon are classified into two types. First one is a saturated one, unsaturated one. Saturated is nothing but all carbon atom present in the hydrocarbons or having single bond. Okay, and unsaturated is nothing but double bond or triple bond. Single bond hydrocarbons are called as an alkanes. Double bond hydrocarbon are called as an alkenes. Triple bond called as an alkynes. Let's move for the alkanes. Alkanes are the saturated hydrocarbon containing single bond. Its general molecular formula or general formula of alkane is CnH2n plus 2. For example, here where n is equal to 1, we called that alkane as an methane, ethane and propane. In IUPAC we discuss in detail. Okay, naming. Next, these are the another examples, propane, pentane. And let's move for the electronic dot structure. Very important dot structure. Ethane. First, we need to connect every carbon atom. If they ask carbon atom, ethane, 2 carbon atom, we need to connect carbon atom by single bond, then fill its valency. Very simple. For example, this is an electronic dot structure of ethane. Let's move for the alkenes. Alkenes. In name, ENE is there. It's nothing but double bond. Its general formula is CnH2n. This is an unsaturated hydrocarbon containing double bond. Okay, for example, ethene is there, propane is there. And these are also called as an olefins. Very, very important. What is the different? What is the another name of alkenes? not an unsaturated compound. The another name is olefins. Okay, students. Next, move on to the other example for alkenes. These are the example for alkene. Let's move for the alkynes. Alkynes. We missed the electron dot structure. First, we need to connect every carbon atom with double bond, then fill the valency. That's all. This is about the electron dot structure of ethene. Just look here. Here, carbon atom, two electron contributes for double bond, and each electron contributes for single bond formed with an hydrogen atom. Next, move for the alkynes. Alkynes are the unsaturated hydrocarbon containing triple bond. Its general formula is CnH2n-2 and it contains triple bond. Right, students? For example, ethane, propane. Here one important point is there. Alkene and alkyne never exist with single carbon. It's nothing but never exist methane and methane molecule. Methane and methane molecule never exist. But why? Because CH bond, only carbon is formed in single bond with hydrogen. Why? Hydrogen have only one valence electron. That's all. Okay, this is about few example, and this is an electron dot structure. It's very similar. Next, move on to the very important isomerism. What is isomerism, students? For example, let's take here one example is there butane. We can write this structure as an this also, right? We can write like this also. It's nothing but isomers is nothing but very simple. The compounds having same molecular formulae but different structural formulae. These compounds are called as an isomers. Structural isomers. The phenomenon is called as an isomerism. Okay, here is there, right? This phenomenon is called as an isomerism. I think it's clear. Okay, let's move for the characteristic isomers. In characteristic isomers, it has a different physical and chemical properties. That's absolutely why. Why different physical? Because CC bond, it's branched, right? For branched, we need high energy to break this bond. Okay, I hope it's clear. And also, greater the number of carbon atoms, greater number of isomers are formed. Very important. If we have more carbon atom, now for example 10 carbon atom, we can form more than 5 rings, more than 5 isomers, 5 isomers, right, students? This is another important point, and it has the same molecular formula, different structural formula. Let's move on to the isomers, and next move for the ring isomerism. What is ring isomerism, students? We already know in catenation property, the carbon has an ability to form a branched chain. What is the cyclohexene formula? Cyclohexene formula is also 6H12, and if we write cyclohexene in ring system, not in cyclohexene, only hexene formula is 6H12 and cyclohexane formula is C6H12. It is nothing but it has the same molecular formula but different structure. It is there in ring structure. These are called as an ring isomers. Okay, these are called as an ring isomers. Okay, students, I hope it's clear. It is an, okay, very important, unsaturated hydrocarbon. In every PYQ or in every question paper they ask, give an example for unsaturated ring compound. Best example is benzene, and also we need to mention the structure. Whenever they ask, please mention the respective or corresponding structure in the paper. If you mention or if you write the structure, you got out of 4 marks in carbon and its compounds. Okay, let's move for the another. Functional group. What is functional group? In taxonomy, in biology, what we do, plants and animals we classified into different classes. Depends upon the characteristic. For example, apples in fruits, vegetables in carrot, in vegetable place, this type. Similarly, the organic compound also placed in different groups based on their what characteristics. If we replace the hydrogen by other compounds, the characteristics also changes. This group are called as a functional group. Okay, in methane, replace one hydrogen with heteroatom. Heteroatom is nothing but chlorine atom, nitrogen atom. What happened? This heteroatom changes the characteristic property of this compound. These groups are called as a functional group. Functional group is nothing but heteroatoms or replaces the hydrogen atom. This heteroatom confers specific property. It gives specific property for the compound. These are called as functional groups. I hope it's clear. Okay, students, let's discuss some functional group. Example for some functional group, halo. It's nothing but halogen group. Symbol ClO, BRO, this thing. Okay, students. Next, alcohol, OH is and symbol RDH, this one. Ketone, carboxylic acid, we are all familiar, this one. Right, students, next move on to the homologous series. We know, right? We know. In a food store, what happened? Different food items are separated in human nature. If we look at food items, we can easily attend the pani puri and other things, right, students? Similarly, the compound having similar property, we kept in same series. For example, alkane series, alkyne. These series are called homologous series. Very important terminology, very important for 5 marks. They may be asked given property of homologous series. What is homologous series? What is ethene? This thing they have. They ask, okay, in 5 marks, they divide 5 marks question into A, B, C. Don't worry, students, in the evening, I upload top 15 PYQs from the homologous series, not an homologous series, from carbon and its compounds in within 15 minutes. I explain in within 15 minutes. This about homologous series. And also, students, just look here. First property, each members in the homologous series or the organic compound having similar structure and not in similar structure, having same formula. For example, alkane series, every having general formula as CnH2n, okay, H2n plus 2, and also between two consecutive members of homologous series, the CH2 unit different is there. CH2 unit different is there here. Look here, CH2 unit different is there, and also second point. 14. The difference in molecular masses of any two adjacent or any two consecutive members is 14. Second important, and all the compounds in homologous series have same not in physical property, chemical property. Physical properties in gradual changes. Maybe sometime melting point is changes, depends upon the structure. Right, we have so many carbon atoms. We need high energy to break all carbon atoms. Right, students? Sometimes physical changes gradually increases, not in sometime always. Okay. Okay, but chemical property is same. Why? Because in all homologous series, it's the same group is there. It shows same property. That's all, students. Okay, next move on to the physical property. Just look here. Boiling point, sometimes it gradually increases or decreases. Next move on to the nomenclature. Very important term. It is an 100% question for your board exams now. For this year. Okay, why now? Because in previous year, they never asked this question. That's why it's very important. We have two names for organic compound. First name is called common name or trivial name, and second one official name. Official name is given by one institute called International Union of Pure and Applied Chemistry in 1958, or IUPAC. IUPAC nomenclature. You already familiar this, very important. Students, first, before entering into the IUPAC, we have one important terminology. If we remove one hydrogen from alkyl group, in alkene group, it is called as an alkyl. It is called an alkyl. For example, in CH4, one group is removed. It is called as an methyl group. Okay, students, I hope it's clear. Let's move for the first one. IUPAC is divided into 3 parts. Okay, the IUPAC name is divided into 3 parts. First part is called as an prefix. Second part is called as an parent chain, and last one is called as an suffix. Suffix is completely depending upon the functional group or the compound containing single bond or double bond or this thing. Prefix is completely depending upon the substituent called methyl, ethyl, something. This parent chain, for parent chain, we need to count the long chain, the carbon atom containing long chain. And also for single bond, we tell name as an ANE, suffix ANE, that's thing. For example, for this, here two carbon atom is there. For one we call meth, 2 is called eth, 3 is called prop, 4 is called but, 5 is called pent, and 6 is called hex, 7 is called hept, 8 is called what? 8 is called Hawk, 9 is called this thing. Okay, this is about the IUPAC system. For example, and also we need to count highest carbon atom present in the chain. It may be straight chain or it may be branched chain. We need to consider longest chain, and also this group considers an what? Substituent group. Finally, the name become like this. Here two substituent is there. We need to mention the substituent in prefix term. For example, this thing is happened. This is an format. Please note on this format. For example, here some carbon atom is there totally at 2 position, and also students, here one important point is there. The numbering is always given lowest possible number. We need to number the compound by substituent. It comes as lowest possible. For example, here second position carbon atom is there. If we take from this side, it's comes second position substituent. That's why this is a right method, but not we consider from the longest. We need to give an lowest possible number for substituent. Okay, I hope it's clear. For example, here 2-methyl butane is there, and this is an correct, and this is an 2. And if we present 2 or more substituent, we go through the alphabetical order. Which substituent come first? Simple, very simple. Okay, students, this is about the rules. Last rule, students, if we contains 2 or more compounds, if it's contain 2 or more compounds, we use di, tri, tetra. Okay, very simple. Then move on to the functional group. If its functional group is there, we need to change this alkane is there now. We need to change E word. E word for an example, ketone is there ONE. For example, alcohol is there OL. This thing we need to change. These are the general IUPAC name. For alcohol, ROH. For ROH, OL. RCOH. For aldehyde, AL. Don't confuse alcohol and aldehyde. It is very important. Ketone, something is there. This for the halogen group. Halogen group we mention in prefix term, not in suffix term. Please concentrate in prefix. We need to mention like in fluoro, chloro, this thing. Next, more the chemical property. What is oxidation? Oxidation is nothing but addition of oxygens, right, students? What is oxidizing agent? Oxidizing agent is nothing but the substance undergo reduction and helps to other compound, helps to other substance to oxidize. Very simple. Okay, these are called as an oxidizing agent. And also here one very important reaction is there. How to convert alcohol to carboxylic acid? Very important. Please note on this reaction. Okay, whenever we react alcohol in the presence of alkaline KMnO4, these are the best oxidizing agent is used to convert alcohol to carboxylic acid. For example, ethanol. Whenever use acidified K2O7 or alkaline KMnO4, it gives CH3COOH. Okay, students. Next, this is an important difference between combustion and oxidation. As in both cases, oxygen only attached, but in combustion, what happened? The complete organic compound convert into carbon dioxide and water molecule. Okay, student. In oxygen, what happened? The loss of electron or happen, or otherwise oxygen is happen. Okay, this is called oxidation and combustion. Here also one important note is there. What is that note? All oxidation reaction are not in combustion reaction. Okay, all combustion reaction are oxidation reaction. Very simple. Next, move for the second one. What happened in combustion reaction? Whenever the compound react with oxygen, or whenever compound is undergo reaction, whenever the compound is heated in the presence of oxygen, it completely converted into carbon dioxide and water molecule with releases high amount, huge amount of heat and light. Okay, please mention these words, heat and light. Please do not forget in the combustion reaction. And also, whenever you guys are looking now, every time LPG burn, if we switch off the LPG gas now, we switch off the LPG gas, we obtain and blue flame. Blue flame is nothing but it contains saturated compound. Whenever we react saturated compound, whenever we heat the saturated compound in sufficient oxygen, it given a blue flame, and unsaturated compound gives a which flame? Sooty flame. This flame. Okay, I hope it's clear. When what happened? Sometime after long days, whenever we switch on the LPG gas, it gives an unsaturated compound like, right, students? Black flame or sooty flame. Why? Because in this case we do not do not provide sufficient oxygen. That's why it gives some black compounds. Okay, black or sooty flame. Next, move on to the substitution reaction. In name itself, the name we can easily explain. Substitution. Something is substituted. We need to remove hydrogen and we need to substitute something. This is called substitution reaction. Next, what is substitution reaction? In hydrocarbon, hydrogen is substituted by other compound. For example, alcohol preparation, everything preparation. For example, here see. Methane group, whenever it's reacted with chlorine molecule, here there. See a chlorine molecule in the presence of sunlight, it converted into methyl chloride. That's all. Next, move on to the addition reaction. What is addition reaction, students? Very simple. We add something. In this reaction, what happened? Unsaturated hydrocarbon or converted into saturated hydrocarbon by using nickel or palladium catalyst. Very important reaction. Please note down this. For example, any unsaturated, what happened? This bond is broken and hydrogen atom is added. That's all. Very simple. These are called what? Addition reaction. Next, another very important addition reaction is there. It is used in application, industrial application, in the preparation of vegetable ghee. Very important, vegetable ghee. In exam, they asked, given use of industrial application for which? Hydrogenation or anything. Next, for test for unsaturation. How to test for unsaturation? By using bromine water. The decolorization of bromine water happened. Bromine is added to the unsaturated compound. Very simple. Next, ethanol. Let's move on to the ethanol. Ethanol, C2H5OH. It has an alcohol functional group. Next, move for the these are the physical property. Ethanol is a colorless liquid. It has a pleasant smell. It has a low boiling point. It is lighter than water, highly soluble in water, no effect on litmus. Note on this point, and also good solvent. It is used in the ingredient present in alcohol. Okay, students. Rectified spirit. Some important terminologies is there. Rectified spirit is nothing but 5% of water in ethanol, 95% of ethanol in absolutely is nothing but 100% of pure ethanol. Okay students, chemical property of ethanol combustion reaction, overall complete ethanol is converted into carbon dioxide and water. What about oxidation? We already discussed ethanol is converted into acetic acid in the presence of alkaline KMnO4, alkaline KMnO4. Next one, reaction with metal. What happens if whenever metal is reacted with ethanol, metal is highly reactive with hydrogen, hydrogen is replaced. Displacement reaction is happened to form metal ethoxide or sodium ethoxide. Okay students, I hope it's clear. Next, how to test hydrogen reaction, hydrogen gas evolved by using an pop-up sound. Okay, next move for the dehydration reaction, very important. Whenever we heat ethanol at 170 degrees Celsius or 443 Kelvin in the presence of concentrated H2SO4, concentrated H2SO4 acts as an dehydrating agent to heat ethene and water. Okay, uses of ethanol. We use ethanol in many cases in ingredient present in alcohol, medicines, perfume, dyes, and also antiseptic, sterilize, and before we have many uses. Okay, solvent as an organic compounds. Okay, and also instead of ethanol, if we drink methanol, what happened? Die thing is happened, we die. Okay, it is very important, ethanol and methanol. Next, move on to the ethanoic acid. Physical property same, similar to the alcohol only, but it is a colorless liquid, highly soluble in water. Melting point, its melting point is very low, that's why we call this as a glacial acetic acid. Why glacial? If you open the acetic acid bottle, it freezes. That's why. Why? Because its melting point is very low. So to taste. Why? Because it's an acid, right? It is sour to taste and it is smell like vinegar, and also it contains in vinegar. Some important terminology: vinegar is nothing but 5 to 8% of acetic acid in water. That's all. Whenever we dip blue litmus, now what happened? Blue litmus tends to red. Why? Because it's an acid, right? That's why. Its pH value is approximately there at 0.3, its color is orange. That's why it's an weak acid. Whenever the acetic acid is reacted with sodium, now it gives him sodium ethanoate. Sodium ethoxide is different, sodium ethanoate is different. Please do not confuse here. Okay students, then reaction of ethanol. Esterification reaction, very important. What is esterification reaction? Whenever ethanoic acid is reacted with ethanol in the presence of concentrated H2SO4, what happened? Water is releases. Why sir? Because it's a dehydrating agent sir. It forms an ethyl ethonate or ester, sweet smelling ester. It is called esterification reaction. Then carbonates or bicarbonates. Whenever acetic acid is reacted with carbonate or bicarbonates, it releases carbon dioxide gas with metal ethonate. Sodium ethonate is formed but releases carbon dioxide gas. How to test for carbon dioxide gas students? By using lime water. If we pass the carbon dioxide through in lime water, it turns and milky. Very simple uses of ethanoic acid. It is used in the pickles to preservative for pickle and acetone manufacture or in artificial fiber manufacture. Let's move on to the soap. We already discussed esterification reaction, right? If we reverse this reaction now, it is called saponification reaction or hydrolysis of ester. Whenever we dissolve ester in the presence of NaOH or KOH, it's nothing but strong base. It yields glycerol and alcohol and carboxylic acid. This reaction is used in the making soap. This reaction is called as a saponification reaction. What is saponification reaction? When fat or oil is reacted with sodium hydroxide or alkali, is nothing but it has a strong base. It yields soap. It's nothing but sodium salts of fatty acid and glycerol. Glycerol is nothing but alcohol. Okay students, this is an structure of soap. This is an first example, sodium stearate. Structure of soap molecule is look like an tadpole. It has an H structure and tail structure. This is an water soluble head. It's called an hydrophilic head, and oil soluble is called an hydrophilic. Okay, here one important terminology is there students. Misal, what happened now? Whenever we dissolve soap in and water, it forms like this missile. This is called a missile. What happened in this cluster? It forms a crystal. Hydrophobic tails are arranged in the interior part and the ionic ends, okay, and on the surface of the cluster. Hydrophobic head and it forms a different structure like this. This is called missile. Very important. Please note down this point. What happened? This missile is reacted with the grease or this one. This tail is there now. Is attracted this and washed out. This is a cleaning process. Very important. And here one Tyndall effect is there, students. Whenever you switch on the light to a soap molecule, it's look like here. This is called Tyndall effect. We are already familiar in physics, and also we have some limitation for soap is also there. First one, soap are not suitable for washing clothes in the hot water. Why? In hot water, calcium and magnesium is present. Whenever the soap is reacted or soap is dissolved in hot water, it forms a scum. Okay, student. I hope it's clear. That's why to overcome this problem, we use detergents. What is detergent? It's nothing but soap plus soap. Okay, sodium stearate is there and cleaning properties there. Detergents or ammonium or sulfate salt. Here, look here. Ammonium or sulfate salts of a long chain carboxylic acid. Okay, carboxylic acid, for example, detergent example, first one, sodium and decoyl benzene sulfate. This is structure, students. Okay, please note on this one. And also second example, and detergents can be used for hard water also, very important. What is the limitation of soap? Why detergents are used? Why soap are not used for hard water? Why we prefer detergent? These are very important. And this is about detergent. Example is shampoos, washing powder, but detergent is a non-bio degradable. Why? Because in Kengeri, Mori, in Karnataka especially, you guys are see this, right? In Bairmangla, that thing you guys are still because uses of detergents. I hope it's clear. If you have any doubt, let me know on comment section, students. And also, please do not forget to answer the answer in comment section, and please give an valuable feedback in end of the session. Thank you so much, and stay with your Suhas Bhaiya. And today's evening I uploaded top 15 MCQ, not an MCQ, PYQs for metals and non-metal as well as carbon and its compounds. Why sir you choose these two units? These two units have a high weightage of marks. That's why I choose these two units. Please watch that video. It is there in channel. And also please do not forget to like, share, subscribe the channel for more updates. Bye. Take care.